Welcome back. This is the second lesson recording for IM2, March 15, 2021. We've just finished this problem. What about 3 to the power of 0? What is that equivalent to? Well, hopefully you're telling me anything raised to the power of 0. It does not matter what the base is. It's always going to be 1. And why does this happen? Let me explain. Say if you have 3 to the power of 4. So if I have 3 to the power of 4 divided by 3 to the power of 4. This is same as 3 times 3 times 3 times 3 all over 3 times 3 times 3 times 3. And that is, we can cancel out the top and bottom because they are just being multiplied and then divided again. So it's going to be 1 divided by 1, which is just 1. Okay. However, using the quotient rule, remember when you're dividing with the same base, this is same as 3 to the power of whatever the numerator exponent is. You subtract that by the denominator and exponent. That is same as 3 to the power of 0. 4 minus 4 is 0. So we can conclude that 3 to the power of 0 is same as 1. Or anything raised to the power of 0 is same as 1. Next question. What about 3 to the power of negative 4? Okay, there are two ways of thinking about it. One way is to get rid of this negative exponent. How do I do that? Is by putting it as 1 over. Like so. So it's 1 over 3 to the power of 4. That's the denominator. Another way of thinking about this is thinking about it this way. So this is same as 3 over 1. 3 is same as 3 over 1. To get rid of the negative exponent, you flip whatever the number is over. You flip it over. 3 over 1 is same as 1 over 3. So we've just taken care of the negative part of the exponent. And now what we just need to do is raise it to the power of 4. This is same as 1 to the power of 4, which is same as 1. And 3 to the power of 4, so that becomes 3 to the power of 4, which is the same thing. I do want you to think in terms of flipping the fractions over whenever possible. If you just have a number, okay, integer number, you can always represent it as a fraction always by putting it over 1. Because 3 over 1, 3 divided by 1 is you're not changing the value, so you're allowed to change this as a fraction because the value is the same. 3 over 1 is same as 3. So now you're going to play around with the exponent law by doing card number 8 and 9. Okay, so this card, you are dealing, we've skipped the card. Alright, whoops. Alright, so this is card number 8. If I have, say, x squared, you get to choose your exponent. If I have x squared all raised to the x to the power of 3, I know that this is going to be 2 times 3, so this is going to be 6. Okay, and when I do that, my equation is saying x squared all raised to the power of 3 is same as x to the power of 6. Final check, if I do the left hand side, is x to the power of 6. And that's it. You can find another one that works. Share your strategy with classmates that helped you find the correct solution to the explanation box below. If I get this wrong, and say if I have said this was 5, okay, then I should get the error message. Okay, so now you want to find something different. Okay, so what if I change this to 5? Okay, so what is that going to be? 2 times 5 is 10. So I need 1, does not work, and I need more than that. Actually, that's not going to work. So that would not work. So I need to come up with some number that is smaller. But anyway, you get the idea. You're playing around with it, making sure you are getting the right combination. As long as you're multiplying it, that would work. Okay, so there is another correct message. Alright, what about this? This is combining the product rule as well as the quotient rule. If I have 3 squared to the power of 3, or times 3 to the power of 5, okay, 3 squared times 3 to the power of 5 divided by 3 to the power of 9. Okay, so what should I be getting? So I know that the numerator is going to be 3 to the power of 2 times 3 to the power of 5. The bases are the same and they're multiplying, so I just add the two exponents. 2 plus 5 is 7, and then so I'm left with 3 to the power of 7 divided by 3 to the power of 9. It's going to be 7 minus 9, which is going to be -2. Okay, or any other combination for that matter. Okay, so see if you can play around with it and find many different combinations. Now we're going to extend this further, and we're going to explore more sophisticated exponents. So we know that 3 to the power of 5, the exponent is a natural number. 5 is a natural number, the number that you see in nature, or counting number. Okay, 3 to the power of 0, that's all. Exponent is in whole number now. Okay, we ventured into the whole number, and we know that 3 to the power of 0 is 1. What about 3 to the power of -5? Okay, so now we're dealing with exponent is an integer number. Okay, so the exponent that's -5 is an integer because it's a negative number. And now we're going to venture into 3 to the power of half. Well, we know what 3 to the power of 5 means. That just means 3 times 3 times 3 times 3 times 3. So 3 being multiplied to itself 5 times. So it's going to be a whole number. 3 to the power of 0. Anything raised to the power of 0, we're told, is 1. Okay? What about 3 to the power of -5? That is same as 1 over 3 to the power of 5. So it's going to be some fraction number. But what does this 3 to the half mean? If we venture into the exponent as a rational number, that means a fraction, how do we figure that out? What does that mean? Well, to figure that out, let's think about what we do know. Okay? When interpreting new math, you must not break the math that we already know. So that means, what do we know so far? We know that 3 to the power of 1 is 3. What about 1 is same as 2 times half? Okay, we know that half times 2 is going to be equal to 1. And we're going to use this, the third exponent, the power rule, 3 to the power of m, all raised to the power of n. We can represent that as 3 to the power of m multiplied by n. So, using those things very carefully, we start with number 1, 3 to the power of 1 is 3. But on the left hand side, we're going to break that 1 as being multiplication of half times 1, because half times 1 we know is 1. But then we are going to break this up using the third thing that we know, and we can break this up as 3 to the half, all raised to the power of 2, because we're just using this product rule. Okay, so we are saying that m is half and n is 2 here. Now let's think about what is 3 to the power of half. There's something, whatever that is, squared is going to be 3. That means that something times something is 3. Therefore, that something has to be square root of 3, because that's the only number. Square root of 3 times square root of 3 is going to be 3. So from here, we can conclude that the question mark, which was 3 to the power of half, was really square root of 3. Okay, so 3 to the power of half and square root of 3 are same thing. So laws of exponents for rational exponents, you're going to take notes here. An exponent expression with rational, that means fraction exponent, m over n is equivalent to a radical in the following way. Okay, so if you have x to the power of m over n, that's going to be same as the nth root of x to the power of m. So the numerator is raised to the power of m. The denominator power, the n, is what is being applied as root, nth root. So you can represent it this way, or you can represent it as nth root of x, all raised to the power of m. It does not matter. They both are the same thing. And depending on the application, you might have different use for it. Why does this work? Well, I know that x to the power of m over n is same as x to the power of m multiplied by 1 over n, because m times 1 over n is same as m over n. And x to the power of m is x to the power of m, and then 1 over n, just from what we have just defined, is the nth root of that. Or you could think of this as x to the power of 1 over n first, and all raised to the power of m. And I know that x to the power of 1 over n is the nth root of x. And then to that, we're raising it all to the power of m. So the denominator of the fraction exponents becomes the index root of the radical. That means the denominator, the bottom number. Okay, the denominator is the bottom number of the fraction, becomes the index root of the radical. So you're taking the nth root, while as the numerator, the number at the top of the fraction, you're raising it to the power of that value. So let's do some practice. Let's convert the fractional exponents to radical, and you need to be able to convert both ways flexibly. Okay, remember the x to the power of 1/3, this is the exponent form. Then cube root of x, this is the radical form. Radical form is the one where you're putting the square root sign with whatever the root is, and exponent form is putting it as a fractional exponent. Alright, so in this case, what is this equivalent to? This is the numerator is 1, the denominator is 3. So denominator 1/3 tells me this is same as 2 to the nth root, which n is 3, so it's the third root of 2. That means we're looking for some number that multiplies to itself 3 times, gives you the root 2, right? What about this? This is same as 6 squared, so that's 6. The numerator is 2, and the denominator root is going to be 3. So it's 6 to the power of 2 over 3. This is not the same as 6 multiplied by 2 over 3. Okay? It is 6 to the power of 2 over 3. What about this? Okay, now let's see if you can convert this into radical form. That means square root symbol. Okay, so I can write this as 5 to the power of half, all raised to the power of 3, and that is same as square root of 5, because 5 to the power of half is square root of 5, all raised to the power of 3. Or I could have thought of this as 5